What is the formula for NPR? N factorial divided by n minus r factorial. So this is factorial n divided by factorial n minus 3 is equal to 210. This is given. Consider the 2 bytes as 1 unit. The remaining 6 minus 2 is 4 bytes. So 1 unit plus 4 bytes, that is equal to 5 numbers has to be arranged in a circle, right? So out of this 11, already 4 plus 1, 5 are chosen. 11 minus 5. 11 minus 5 is remaining 6. Hello dear students, welcome to this session of Basic Mathematics Revision class. I am Mr. Niranjan, Faculty Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session I am going to discuss very important and easiest chapter, that is permutations and combinations. So in this chapter you are going to get 1 mark on objective question, 2 marks question and 1 3 marks question. So totally 3 plus 2 plus 1, 6 marks from this. So the weightage for this chapter is 6 marks and very easiest chapter. Now let us discuss the problems which are appeared in the previous year question paper. Now 1 marker question. So what is the first question? In how many ways can 10 people be seated around a table? So here the number of peoples are 10. So there are 10 people. 10 people may be seated around a table. So in how many ways? So we have to arrange in how many ways can 10 people be seated around a table, right? Now this is an example for a cyclic permutation. So here n is equal to 10. The number of ways that 10% can be seated is nothing but n minus 1 factorial. So here n is equal to 10. 10 minus 1 factorial, that is equal to 9 factorial. So the answer is 9 factorial. So this is an example for a cyclic permutation. Here n is equal to 10. N minus 1 factorial will give the answer. Suppose if it is 8% means 8 minus 1 is 7 factorial. Since it is 10, 10 minus 1 is 9 factorial. 1 more question, MCQ. Now move to the next one. Find n if NC8 is equal to NC7. We know this. If NCR is equal to NCK, then n is equal to r plus k here. So here n is also equal to r plus k. Now what is given? NC8 is equal to NC7. So therefore n is equal to 8 plus 7, that is n is equal to 15. The value of n is 15. That's it. Now move to the next problem. How many different arrangements can be made with the letters of the word Monday? So in Monday, how many letters are there? M-O-N-D-A-Y. So there are 1, 2, 3, 4, 5, 6. 6 letters are there. So using these 6 letters, different arrangement can be, how many different arrangement can be made? Right. Now listen. So here this word Monday contains 6 letters. So in how many different arrangements can be made? So the different arrangements, the number of arrangements with this all the 6 letters is 6p6. So what is 6p6? This is nothing but 6 factorial. 6 factorial means 6 into 5 into 4 into 3 into 2 into 1. So what is this equal to? This is equal to 720 ways. So in 720 ways we can arrange the words of the letter Monday, right? That's it. Okay. Now move on to the next problem. This is also important for 1 mark. How many straight lines can be formed from 10 points if no 3 of them are collinear? So no 3 of them are collinear. So therefore the number of straight lines can be formed. The number of ways is equal to 10C2. So number of straight lines that can be formed from 10 points. To draw a straight line, minimum 2 points must be required. So that can be done in 10C2 ways. That's it. So that is equal to factorial 10 divided by factorial 2 into factorial 10 minus 2. So this can be written as 10 factorial divided by 2 factorial into 8 factorial. So that is 10 into 9 into factorial 8 divided by 2 into 1 into 8 factorial. These two gets cancelled. 2 5s are 10. 5 into 9, that's equal to 45 ways. So the number of possible ways are 45. So how many straight lines? So 45 straight lines can be drawn from 10 points if there is no 3 of them are collinear. That's it. This is also important for 1 marks. That's all, right? Now, if NP3 is equal to 210, find M. This is also an important problem. If NP3 is equal to 210, find N, right? Now, what is NP3? So, here given NP3 is equal to 210. What is the formula for NPR? N factorial divided by N minus R factorial. So, this is factorial N divided by factorial N minus 3 is equal to 210. This is given, right? What is the meaning of N factorial and N minus 3 factorial? This is N into N minus 1, N minus 2 into N minus 3 factorial divided by, in the denominator we have N minus 3 factorial is equal to 210. N minus 3 gets cancelled. We have N into N minus 1 into N minus 2 is equal to 210, right? So, by error and trial method, assuming N is equal to 7, what you will get? 7 into 7 minus 1 is 6 into 7 minus 2 is 5. That's equal to 210. That's it. So, therefore, the value of N is equal to 7. N is equal to 7, right? That's it. This is how we are going to solve this problem. Now, move on to the next. How many different 4-digit numbers can be formed using the digits 1, 2, 4, 5, 7, 8, 9? No digit being repeated. No digit being repeated. How many digits are there? 1, 2, 3, 4, 5, 6, 7. Here N is equal to 7. 7 digits are there. So, using these 7 digits, how many different 4-digit numbers? So, 4-digit number can be formed. So, 1, 2, 3, a 4-digit number. So, further, what is the condition given? No digit being repeated. Repetition is not allowed, right? So, this is unit, 10, 100 and 1000, right? Now, first, the 1000th place can be filled by all the 7 digits. Since there is no digit being repeated, so the 100th place can be filled by the remaining 6, right? Again, the 10th place can be filled by the remaining 5, and the unit place can be filled by the remaining 4 digits. So, the 1000th place is filled by all the 7 digits since there is no repetition. So, one number is gone, and what are the remaining numbers? There are 6 numbers are left. The 6 numbers can be arranged in 100th place, and again the 10th place can be filled by the remaining 5 numbers, and the unit place is filled by the remaining 4 letters. So, therefore, the total number of ways is equal to 7 into 6 into 5 into 4 ways. So, what is this equal to? This is equal to 840 ways, numbers, or 840 ways. That's it. Okay. Now, move on to the next problem, 2-marker question. So, these are all 1-mark question. Now, discuss regarding 2-marker question. In how many ways can 6 boys be arranged in a circle if 2 particular boys always want together? So, in how many ways can 6 boys be arranged in a circle if two particular boys wants to be together, right? So, out of 6, we are going to arrange in such a way that 2 particular boys will always to be together. Now, consider these 2 boys as one unit. Consider 2 boys as one unit. Okay, consider the 2 boys as one unit. So, therefore, 1 unit plus the 2 remaining. So, out of 6, we have taken 2 boys, the remaining 4 boys, 1 unit, 2 boys plus 4 boys. So, this is equal to totally 5. 5 has to be arranged in a circle. Right? These 5 are to be arranged. So, consider the 2 boys as one unit. The remaining 6 minus 2 is 4 boys. So, 1 unit plus 4 boys, that is equal to 5 numbers has to be arranged in a circle, right? So, this can be done in 4 factorial ways. That is n minus 1, that is equal to 4 factorial. That is 5 minus 1 factorial, that is nothing but 4 factorial ways. So for these, two boys are, each particular boys are always together. So therefore, since two boys are always together, so therefore the required arrangement is just multiply 4 factorial into 2 factorial, that's it. So therefore the total ways is equal to 4 factorial into 2 factorial. This is 4 into 3 into 2 into 1 into 2 into 1. What is this equal to? 4 is a 12, 12 2 is a 24 into 2. That's equal to 48 ways. This is the required answer. That's it. Hope you followed. Okay. Now move on to the next problem. Find the number of parallelograms that can be formed from a set of 5 parallel lines. Set of 5 parallel lines intersecting another set of 6 parallel lines. See here. So find the number of parallelograms that can be formed from a set of 5 parallel lines intersecting another set of 6 parallel lines. So the number of parallelograms is of the form MC2 into NC2. MC2 into NC2. Here what is M? M is equal to 5 and N is equal to 6. That's all. So here this is nothing but 5C2 into 6C2. Now simplify this. So what is 5C2? Factorial 5 divided by 2 into 5 minus 2 factorial into 6 factorial divided by 2 into 6 minus 2 factorial. So that is equal to factorial 5 means 5 into 4 into factorial 3 divided by 2 into 5 minus 2 factorial is 3 into 6 factorial means 6 into 5 into 4 factorial divided by 2 into 6 minus 2 is 4 factorial. These two gets cancelled. 2 3s are gets cancelled. 3 3 gets cancelled. 2 2s are gets cancelled. What is left? 5 into 2 into 3 into 5. So that is equal to 10 into 50. That's equal to 150. 150 is the required answer. Okay. So therefore, the number of parallelograms that can be formed from a set of 6 parallel lines intersecting another set at 5 parallel lines intersecting at 6 parallel lines is 150 ways. Now move on to the next problem. In how many ways can 6 people be selected out of 12 people so that, what is the condition given? 2 particular members must be included. 2 particular members must be included. Second condition, 2 particular members must be excluded. So first case, 2 particular members must be included. In the second case, 2 particular members may be excluded. Right. Now, so here how many ways can 6 people be selected out of 12 people? So in the first case, 2 particular members are selected. 2 are already selected. So 2 are already selected means included, right? So therefore, from remaining, so 12 minus 2 means that is 10. From remaining 10, so we have to choose. So 6 minus 2, that is 4 more. Right. See, already 2 are selected. So therefore, 12 minus 2 is 10 is left. Out of this 10, 6 minus 2, already 2 is taken. 4 persons, 4 people are to be selected. So this can be done in, so therefore the number of ways is 10C4. That's all. 10C4 ways. So what is this equal to? The value of 10C4 is 10 factorial. Factorial 10 divided by 4 factorial into 10 minus 4 is 6 factorial. This is equal to 210 ways. This is equal to 2. So the first one is 210 ways. And the second, 2 particular members must be excluded. Now case number 2. 2 particular members are excluded means 2 peoples are rejected. So from the remaining 10, we have to choose we have to choose how many? 6. So from the remaining we have to choose the 6. So this can be done in, this is equal to 10C6 ways. What is this equal to? So this is equal to factorial 10 divided by 6 factorial into 10 minus 6 is 4 factorial. This is also equal to 210 ways. That's it. Now move on to the next problem. So this is also an important problem. In how many ways can the letters of the word hexagon be arranged so that the vowels are always in even places? The vowels. So how many letters are there? 1, 2, 3, 4, 5, 6, 7. So the number of letters is equal to 7 letters are there. So right, in which how many vowels are there? So A, E, I, O, U. A, E, I, O, U are the vowels, right? So here how many vowels? The number of vowels is equal to A 1, E 2, I, O. So that's all. So there are 3 vowels in this. The number of vowels are 3. So the letters contain 7. The word contains 7 letters. Out of 7, 3 vowels are there. That is E, O and A. Right. So that means therefore there are 3 even places and 4 odd places. Right. We have to keep these vowels in the even places. So therefore there are 3 even places and 4 odd places. So this can be arranged in, therefore the number of arrangement is equal to, very simple, the number of arrangement is equal to 4 factorial into 3 factorial. That's it. So what is 4 factorial? 4 into 3 into 2 into 1 into 3 into 2 into 1. 4 is a 12, 12 2 is a 24, 3 2 is a 6, 24 into 6. So this is equal to 144. So we can arrange it in 144 ways. That's it. Very simple for 2 marks. Now move on to the next problem. A team of 11 is to be chosen from 10 cricketers, of whom 6 are bowlers and 3 are wicket keepers. In how many ways can a team be chosen so that there are exactly 4 bowlers and 1 wicket keeper? 4 bowlers and 1 wicket keeper. There are at least 4 bowlers and at least 2 wicket keepers. So we have to choose a team in such a way that there are exactly 4 bowlers and 1 wicket keeper, and the second case there are at least 4 bowlers and at least 2 wicket keepers. Very important problem for 3 marks, right? Now first condition, a team of 11 are there. So let us write the bowlers, then wicket keeper and others. Okay, right. How many bowlers are there? There are 6 bowlers and 3 wicket keepers. Now, so 6 plus 3 is 9. How many are there? 18 are there. Out of 18 we have taken 6 plus 3 9. How many are left? That's equal to 9 are left. So others are 9. This is the given condition, right? So how many bowlers? 6 bowlers, 3 wicket keepers, and the remaining others are 9. Totally there are 18 players, 18 cricketers. Now what is the condition? First, there are exactly how many bowlers? 4 bowlers and 1 wicket keeper. So we are going to select 4 bowlers, 1 wicket keeper, and the remaining, how many are left over? How many members, how many cricketers has to be chosen? 11. So out of this 11, already 4 plus 1, 5 are chosen. 11 minus 5 is remaining 6. Right. So this is the first condition. See. So the number of bowlers are 6, wicket keepers are 3, and the remaining players, other players are 9, in which we are going to select 4 bowlers, 1 wicket keeper, and the remaining players are 6 players, 6 other players. So therefore this can be done in, so this can be arranged in 6C4 into 3C1 into 9C6. That's it. Simplify this. So 6C4 is 15 3C1 is 3 into 9C6 is 84. So if you multiply this 15 into 3 into 84, 3780, 3780. So the first team can be chosen in 3780 ways, in which exactly 4 bowlers and 1 wicket keeper, and the rest will be the others. This is the first case. Now move on to the second case. There are at least 4 bowlers and at least 2 wicket keepers, right? Now same from the same case number 2. Bowlers, wicket keepers and others, right? So 6 bowlers, then how many wicket keepers? There are 3 wicket keepers, and others are 9, right? So here so many cases arises. First, second, third. So first, how many bowlers? Minimum at least 4 bowlers and 2 wicket keepers. 4 and 2. 4 plus 2 is 6. Remaining 6 plus 5, 11. Next, second condition, 4 bowlers, then 3 wicket keepers. 4 plus 3, 7, and the remaining are 4 others. Next case, 5 bowlers, 2 wicket keepers, and the remaining 5 plus 6 is 7. So 7 plus 4 is 11, right? Next case, fourth, case number 4. So same 5 bowlers, we can take 5 bowlers and 3 wicket keepers. 5 plus 3, 8, and the remaining 3 are others. 5, 3, 3. Now we can take 6 bowlers, 2 wicket keepers. 6 plus 2, 8. 8 plus 3, 11 others. That is 3 others, totally 11. Now similarly, 6 bowlers, 2 wicket keepers. 6 plus 2 is 8. 8, 9, 10, 11. Remaining 3 are others. Now the last case. So sixth one, how many bowlers we will take? Bowlers, wicket keepers, others. So we can take 6 bowlers, right? And 3 wicket keepers. 6 plus 3, 9. Then remaining 2 are others. That's it. Okay. This is how we are going to arrange. So if you multiply, if you simplify this, so what is the answer we are going to get? 6C4 into 3C2 into 9C5, right? 6C4 into 3C3 into this 9C4 plus like this. The last one is 6C6 into 3C3 into 9C2. So the answer we are going to get is 1620 ways. This is the final answer. Simplify this, you will get this one. 10620. That's it. Okay. Hope you followed. Right. Hope you followed all these type of problems. So these type of problems are very important for the point of examination. You may get 1 mark one question, 2 marks, and 1 3 marks question. So that's all regarding today's session. Let us meet with a different concept in the next session. Thank you. Thank you very much.